Hello students, today our new topic is the characteristics of particles of matter. In this topic we will discuss about the characteristics of particles. Okay, and this is the lecture of grade 9th, chapter 1, matter in our surrounding, and this is its part 2. Okay, so coming to our topic, that is characteristics of particles. There are four characteristics of particles. Among the first one is the particles are made up of very small. The particles of matter are very small. That means a small amount of some particular substance contain a lot of small and millions and billions of particles. To prove this statement, to prove this character, we will discuss an experiment, and the experiment is, if we take a small beaker in which we will take 100 ml of water, 100 ml of water, and if we put some potassium permanganate, KMNO4. This is the formula of potassium permanganate, KMNO4. If we add some potassium permanganate in 100 ml water, then what is the color of that solution? What is the color of that solution? The color of this solution will be the dark purple. Okay, and after that, moving ahead to this experiment, if we take some amount of solution, potassium permanganate plus water, some solution, how much solution? The 1/10 of this solution. What is the meaning of 100 ml of 1/10 of 100 ml? The 10 ml solution of potassium permanganate, and added to the another beaker which has already 90 ml of water and 10 ml of solution. Then what is the total amount of solution? The total amount of solution is 100 ml, 100 ml again. This is also 100 ml, this is 100 ml. Okay, here what is the color of this beaker? If we take some potassium permanganate solution and added this is 10 ml. We take 10 ml of potassium permanganate solution and added to the 90 ml of water. Then the color of this solution will be the light purple. Okay, the light purple color will be shown with this beaker. Again, if we dilute the potassium permanganate solution, if we go further like this, if we take 10 ml of potassium permanganate solution with this and add in 90 ml of water again, and what is the total amount is 100 ml. Why? Because we take 10 ml of potassium permanganate from this solution and add in this beaker. So 90 plus 10, this is 100 ml. So what is the color of this solution? The color of this solution is pink, P-I-N-K, pink. So going ahead and going further and doing same thing again and again, and lastly we observe that if we take 10 ml potassium permanganate to the next beaker, in which 90 ml water already present, then 90 plus 10 is equal to 100 ml of potassium permanganate solution. Here the color of this beaker, that is light pink. So here we can see that the small amount of potassium permanganate can color a lot of water. Firstly, it starts from dark purple and going to the light pink. Then from this experiment, what is proved? What is proved? This so that this experiment has shown that the small amount of potassium permanganate contain a lot of particles in it, a lot of small particles, since it colored the huge amount of water. Okay, so I hope this is clear to you that small amount of potassium permanganate can color the huge amount of water. In this way, how the small amount of potassium permanganate will color the whole water, and it starts from dark and ends with light pink because it contain a lot of particles in it. In this way, we can say that the particles of matter contain and will have a very small amount of particles in it. Okay, so the next characteristic is, I wipe it out, and the next characteristic is the particles of matter have spaces between them. For this, what is the meaning of this statement? The meaning of this statement that a space, a small amount of spaces present in the particles of the matter, and prove this statement, we will take an experiment. That is, if we take a beaker and put some water in it, suppose this is beaker, and put some water in it and mark the level of this water here. We can mark the level of this water and add some sugar in it. Then sugar completely dissolve in the water, and after dissolving the sugar in the water, we can again observe the mark and the level of the water. So we can see that the level of water after dissolving the sugar in it will never rise, can't rise. How is it possible? It is possible only when the small amount of sugar can dissolve in water and trapped between the molecules of the water. The small spaces between the molecules of the water that trap the sugar particles. In this way, this statement proved that the particles have spaces between them. So I hope this is clear to you. And the next characteristic is the particles are constantly moving, and we prove this statement by the help of diffusion and Brownian movement. I will bring you the separate lecture on diffusion and Brownian movement. Okay, so how can we prove that the particles of matter are constantly moving? This is very simple thing, and by the help of diffusion I proved it. Okay, if we burn incense stick, if we call in Hindi is agarbatti. Okay, if we light or burn incense stick in the one corner of our room, suppose this is incense stick, and we light up and or burn in one corner in our room, that after some time we can smell the pleasant smell, we can feel the pleasant smell of this incense stick from everywhere. At each and every corner of our room, we can smell the fragrance. We can smell the fragrance of this incense stick. And how is it possible? It is possible with the help of diffusion. With the help of diffusion. So what is diffusion? What is diffusion? The movement of particles. The movement of particles among each other. The movement of particles. The air has also some particles, the gaseous particles, and incense sticks can produce some smokes, some what is called in Hindi dhua. Okay, so the movement of particles among each other, the air and the incense stick, okay, among each other on its own, by the help of no, there is no with the help of anything, by its own. So they become mixed uniformly. And this point I will make sure that clear, that mixed uniformly. By the help of this mixed uniformly, we can smell the smell of incense stick at everywhere. At the Because the particles of incense stick, the particles of incense stick will spread throughout the room by the help of diffusion. Okay, we can again take an example in which we take a beaker and put some water in it and also add potassium permanganate. You can add also copper sulfate, CuSO4. Okay, if we add potassium permanganate in water and do not do anything, don't mix up with your hand, with your spoon, don't mix up. Okay, and stir them it's on its own. After some time, in after 30 minutes and 1 hour, the substance potassium permanganate dissolve and put his purple color and dissolve throughout the water and colored the whole water that is present in the beaker. So how is it possible? It is possible when the particle of matter are constantly moving. By the help of constantly moving of the particles, it spread throughout the beaker, it spread throughout the room. When we light the incense stick. Okay, so is it clear to you? Again, what is the last characteristic? The last characteristic is the particles of matter attract each other. This is all about the intermolecular forces. Okay, that we will talk about in solid, in liquid, in gaseous. In solid, the intermolecular force, that this is the special type of forces that is present between the molecules of the substances. Okay, in the solid, in the liquid, in the gases also, in which the intermolecular forces in solid is very much stronger. We can say that strongest at all the matters, all the states of the matter. So in this way, we cannot break a solid substance like metal. In the intermolecular space in metals are very much stronger. But if we take a chalk, it can easily break. We can easily break this. Why? Because the intermolecular forces in chalk and some other substances is little bit weaker. Okay, when we talk about the metals, the intermolecular forces in metals are very much stronger. So we can say that the particles of the metal attracts each other. Why attracts each other? Because the intermolecular space are held together. Okay, so if we take the liquid, then intermolecular forces in liquid little bit lesser than the solid. So we can cut the water, but it can easily not cut. So, but if we talk about the gases, the intermolecular forces is very much weaker. We can say that weakest, more weak and most weaker. Okay, so the particles of the matter attract each other, but it is depends upon the states of matter. In solids it is very strong, in liquids little bit weaker than solid but stronger, okay, and in gases the weakest intermolecular forces are present in gases, so the attraction force between the molecules is very much lesser among all the states of the matter. So this is all about this lecture. We will discuss more of things and also the diffusion and Brownian movement in our next lecture. Till then, thank you for watching, and if you have any question, please ask. Thank you.